Hello guys, today we'll see a complete application based on SQL Server, .NET and Angular. So in this we need to create a database first. In our database we will have three tables. First one is countries table, which we are going to use as a drop down in our front end. Second will be our customers table, which we are going to use it as a primary table because against every customer we have orders list. So now open a new query. Now we are going to create our tables and writing their scripts. Here first of all we need to write use master because in master we have all the configurations. Then we are going to write go statement, which basically indicates current batch. Now first of all we need to create a table, and our first table will be customers table. For table creation we need to write create table customer command. In customer table our first attribute will be ID and its data type is big int. We are assigning it another constraint, which is identity. Basically SQL Server implement it by itself. Its first parameter is 1, which means we are going to start it by 1, and second parameter is also 1, which means we are going to increment it by 1. To this ID attribute we are going to assign two more constraints, which is not null and primary key, which will indicate our ID attribute as the primary key of this table. Our second attribute will be first name, and data type is nvarchar, and its length must be 100. But for string we have different kind of data types like character, n character, varchar or nvarchar. It all depends what we need at a particular moment. For example, we can use character, which we use when we need a fixed number of string. In case of nchar, we can store unicodes, but its length will be also fixed. Third, we can use varchar. Its length could vary, but its storage will be 1 byte, and we can't store Unicode characters in it. Fourth will be nvarchar, in which length can vary and also it can store Unicode. So mostly in our database we are going to use nvarchar for our string attributes. And now our third attribute will be last name, and next attribute will be registration date, whose data type is datetime. Next is active, whose type is bit. Bit will store true or false, 1 or 0 in it. Okay. Next is deleted. Its data type is also bit. Also to bit attribute we can assign default value. Then we have an attribute address1, whose data type is nvarchar. Another is address2, whose data type is also nvarchar. Then there is city. and another one is country ISO. Whenever we store country information, then mostly we try to save ISO code, and for that purpose we have its data type character and its length will be 2. This is our customers table. This batch is completed. So exactly in this pattern we need to create 2 more tables and execute their script. Now I'm going to write a database name here in which I need to execute these tables. So I've created its batch. Now create database customer DB. This is the name of our database in which we will execute these 3 tables. Now after creation we need to use it for record creation. Now we just execute it. After execution we can check it either it's created or not. Here are DBs, customer DB. In this we have these 3 tables: countries, customer and customer order. So after creation of our database, now we are going to set up our .NET project. And for this project we are going to use Visual Studio 2022. First of all, we need to select language, which must be C# for this project. And solution type must be web. Now we will select a project which is ASP.NET Core with Angular. Now we write project name here. In project name we will have customer app.web and solution name will be customer app. Now let's move on the next step. For solution we need to select .NET 7.0, which is latest, and we are using this for our current project, and we don't need authentication at the moment, so move forward here. Now after creation of this project, let's see what we have in this project here. First of all, we have controllers, and one built-in controller is weather forecast controller, which is default controller. Also we have Angular application here, client app. First of all, we will define project structure, as we are going to use repository pattern for the sake of separation of concern. So next we are going to create repository project. Let's see. And for this project we will use a class library type so that we can reuse it and we can add it to our main primary project. This class library project name must be customer app.repository. For this project we will also use .NET 7.0. We will remove all the default classes from this project as we are going to create our own folders and our own classes in this project. Now we are going to create another class library type project which will represent services. Another object we are going to create is DTO type project. It's data type object. This project is also standalone type because we can use it in services or we can use it in other projects also. For example, if we have DTOs in repository and then we want to use those DTOs in services, then we need to refer that project to services project, which may create circular dependency. Just to avoid that circular dependency, we are going to create another project just for DTOs. Now we have 4 total projects here. One project is the web project, which is our startup project, and in services project we will have our business logic. In repository we will have all entities, and in DTOs we will have our all DTO classes. Basically we are implementing separation of concern in this project. For all different concerns we are having all different projects which have their own responsibilities, and they will not create circular dependencies. Hope so you understand this basic structure of our project. Now in next parts we will see all layers one by one. So now after set up our entire project architecture, first of all we need to work on repository project. We need to install all the entity framework related packages in it. First of all we need to install entity framework core. Next we will install entity framework core.design. These all projects must be of .NET 7 because our project and packages version must be same. After this I need to install entity framework core.tools and .SQL Server. These entity framework core related packages we needed in this project we installed. So next we need to scaffold our existing database in DB context using entity framework. First of all we need to go in tools, then we need to open NuGet package manager and open its console. Now we need to select repository project, and this repository project is also our startup project. A command which we need to execute to scaffold our database. In this first we have written scaffold DB context. You need to write it as it is. Then our server name, database name and user ID, password. Trust server certificate, which means we are trusting SQL Server. Then we are defining which server we are using for our database is SQL Server. Then our output folder will be generated in this repository project, and we are defining that our folder name will be entities. Now let's execute this command. Now our DB context class is generated, and against each table we have a DB set. Next, we need to create a customer repository folder in this repository project. Now our every repository will represent a interface which we need to implement in its own class. Let's create customer repository interface. Both interface and class name will be same, like here I'm giving customer repository. Just we prefix I in front of our interfaces. So this is our interface, which is prefixed by I. Now let's write a class of it in which we will implement our interface. We are actually implementing repository patterns so that our classes are loosely coupled with each other. For that purpose, we are using interface and then implementing them in classes. This is just for the sake of loosely coupling so that our classes are not dependent on each other, and we will implement solid principles on them and our code just clean in that way. Also in this case, object creation will not a responsibility of our class, but we are implementing dependency inversion in this case. First of all, let's implement this class by our interface. Next, we need to write a constructor in which we will create DB context object. So we will not create its object directly, but we will inject it by dependency inversion. Now we will write basic CRUD functions in this repository, and will implement its functionality in its class. First function we are going to write is get by ID. Also here we are using task-based programming. Now the question is, what is task-based programming? Actually, by default, C# has one main thread. We can create more than one thread using thread or task. Both are used for parallel programming. Task is advanced version which built on top of thread. So we can use await with task-based function to free thread, and by default task is background thread, means it does not block a UI from closing. Other kind of threads are foreground thread that block UI from closing. So this was a generic introduction of task-based programming. We will see it in detail in another video. Okay, one more thing I need to mention here, that a delete and save function will return enum types, which will represent we save our entity, we update our entity, and so on. Let's create an enums folder in DTO project. And create enum here whose name is entity status. First stage will be new, second is updated, and third will be deleted, and fourth will be not updated. Now we will return this enemy in our save function, and this is our save customer function. Now next will be our delete customer function, and its return type will also be entity status. And last we will have a listing function in which we will return paginated data. So for this purpose we will return two things. One is list of customers and another is count of customers. For that purpose we will use tuple here. And tuple we use when we need to return more than one item. First will be list of customers and second is long type, which will return the number of customers. Function name will be filter, and argument of this filter functions are filter, which will filter all the records. Second argument will be sort column, which will describe what will be a sorting column. And third will be sort order, which will describe what will be the order of sorting, like descending or ascending. Fourth one is page number, on which page number we want a list. And the last one is page size, what will be the page size of our page on which we want to show our records after getting from DB. These are our basic functions which we need to implement in its class. First of all, we will implement delete by ID. We will get customer by ID. Now in this task-based programming, we will need to write async with task, and where we expect our call from outside or where we expect our call need to wait for the response, then we write await there. So in this case, until we don't get response from the DB, our thread will be free, and that thread can perform another task. Now if customer is equal to null, then we will return entity status dot not updated. Otherwise we will assign true to its is deleted status and save changes in DB. And let's return entity status dot is deleted in this case. Second function will be get by ID, in which we will simply get customer by giving ID. If there exists a function with a particular ID, it will return a customer. Otherwise, it could be nullable. So if we want to make it nullable, then we will put question mark in front of its return type. And that's it for this function. Now we will implement save function, which is exactly like a delete function. The only difference is if we get customer null on the basis of ID, then we will add customer, otherwise we will update it. So now let's see its implementation. Now we will implement last function, which will be a filter function. In this filter function we will need two things: list of customers and count of customers, as we mentioned earlier. So first of all we will get count of customer. Let's see. So now we will get the count of those customers whose are not deleted, and they filter out on the criteria of our given filter value, and that count will be saved in our total records variable. Now we will get total records in paginated form. For pagination, first of all we will copy this already existing count query, and then we will need sorting. For sorting, basically we will need a dynamic sorting. Dynamic sorting is not already exist in link, so for that purpose we install dynamic link. Now by this dynamic link we will use this order by, and in this we'll pass a string. Then for the sake of pagination we will use skip and take. Skip will define how many records we need to skip on a particular page, and take will define how many values or records we need to show on the page. At the end we will return it in the form of list. Now we will return a tuple with the customer list and customers count. So this was the implementation of our repository project. Now in next part we will see the service project. After creation of our repository, now we need to create our DTOs against our entities. These are the entities we have created by our database. When we scaffold the database, then by default it creates, and we just created it in our entities folder: country, customer and customer order. Now we need to create DTOs against these entities. DTOs basically are called data transfer object. data which we want to represent on front end. This data we need to save in DTOs. Entity basically a representation of database, and DTOs will represent on front end. Now let's create DTOs against each entity. First of all, we will create DTO of country and now add class, and we normally suffix DTO name with DTO. And in DTO we have data which we want to represent on the front end. Now in case of countries DTO, we don't need all the properties of entity, but we only want to represent on front end name and ISO code. So these two properties are part of our country's DTO. But in future, if we want to represent another entity on front end, then we can also add that property in DTO. Next we have customer entity. So now for customer entity we have to create customer DTO. But before that, let's create customer order DTO against customer order entity. Now we will create customer DTO. Okay, one important thing I need to mention here is that DTO's fields name can differ from entity's fields name. It all depends how you want to represent DTO's fields on front end. Now in DTO we need to replace I collection with I list. So these are the three DTOs we created against our three entities, but we also can create more DTOs which we want to use in our services or in our controllers. Now let's see those DTOs. Now first of all, I'm going to create a response DTO for our services. Basic purpose of our response DTO will be that our services return type will always be response DTO type, and in this we will pass a generic parameter which will represent which specific DTO will be returned by this response DTO. Its single or list type, its value will be saved in result. Second will be message, that which message we want to display on our front end. Like it could be a success message, it could be a failure or anything. And third will be a message code, that we can assign different message codes to our messages. And last is a status, that is of type response status. For this response status we have enum in this DTO project. Let's create response status enum. So here three DTOs we created for our entities representation, and one DTO which is response DTO we created for our services response type. And then we created response status enum, which will represent what will be the status of our service function, like it could be failure, it could be success or not found. So these are the DTOs and entities. Now we will see how we can make conversion between DTOs and entities, from entity to DTO and from DTO to entity. For that purpose we will create extension function in next part. So after the creation of our DTOs and entities, now we have to create extension methods in which we will convert from entity to DTO and from DTO to entity. So first of all, we have to create a extension folder in our services project. In this folder, we will have all our extension functions. Now let's create our customer order extension, for which we will create extension class and we'll write function in it to convert from entity to DTO and entity list to DTO list, and then third one will be from DTO to entity and from DTO to DTO list to entity list. Now our extension class will always be public and static, and all its function will also be public and static. As our first function will convert entity function to DTO function, so this function's return type will be customer order DTO and we will pass parameter customer order entity in it. Now let's return customer order DTO after conversion from entity to DTO. Now we will have another extension method which will convert entity list to DTO list. For that we will have the same public and static function like this. Now this method's return type will be customer order DTO list and we will pass parameter in it list of customer order entity. Then by using previous two DTO method, we will convert this list items one by one into customer order DTO. Now this for each loop will traverse complete customer order entity list and convert its items one by one to customer order DTO. And then we just return this to DTO list. So these two methods will convert from entity to DTO. So this is called the entity extension. Here we can also manage our methods by creating or specifying regions. So let's specify entity extension region here. Another region we will have is DTO extension region, in which we will convert our DTO to entities and DTO list to entity list. Let's see. Now these two functions will be same as we have seen earlier, but what will be the difference? Only our return type and parameter types will change. Like here our return type will be customer order or customer order list, and parameter type will be customer order DTO or customer order DTO list. Now its name should be toEntity and toEntity list. So this is the way we have to convert from DTO to entities and from entity to DTOs. These all conversions will be used when we will create service project. Hope you understand this conversion extension functions, and if you're confused somewhere, then you will see later that where we are using it. Still, if you have any question, you can ask in comments. Next, we will see pagination in our application. Now in our application, we are going to use server-side pagination so that we can fetch exactly the same amount of data that we want to represent to our client and don't load extra data, by which our query will be fast. But before that, I think we need to see an example so that you understand what we are going to do and what kind of pagination I'm talking about. Let's see an example of Google page. First of all, we need to see how many total pages we have. And what will be the starting page? Here we have 2. And what is the current page? Current page here is 7. And what will be the display last page? It's 11. It also could have more than 11 pages, but clickable pages in display are these 2 to 11. So these are the things we need to consider in our pagination, as we can see on the Google page. So now let's start it. Now first of all, we will create pagination folder in our DTO project, in which we have all our pagination related details. First class in this folder will be pager. In this we have the entire information related to our page. Let's write the properties which we needed in this pager class. As this class only deal with the pagination, not the data, so let's write it constructor and pass these parameters to it. I'm going to give default value to page size is 10. You can have whatever you want. Now we can calculate total pages, and we calculate it by dividing total items to a page size. But if we have total items 1 and page size 10, if we divide these 1 by 10, then in case of integer answer will be 0. So to resolve this problem, we will use math.ceiling, which will convert our 0.1 value to 1. And in this ceiling method, we will first of all convert our total items to decimal so that our decimal value don't discard in case of integer. And convert page size into decimal too. Then at the end we will convert this entire value to integers so that our final value will return in integer. Next we need to calculate on which page we are currently. For that purpose we need to set our current page value. If it's null, then we will assign it to 0. Otherwise, whatever we get from our parameters. Next, we will calculate our start and end page. For start page, we need to set current page minus 5, like previous 5 pages we need to set. But for the end page, we need to have current page plus next 4 pages. This is the way we need to set our start and end page. For example, our current page is 7, then start page will be 7 minus 5 and end page will be 7 plus 4. This is the way it will show our start and end pages. Now to consider all the implications of pagination, you need to consider these all conditions so that your pagination will be feasible and workable for you. Now after all the calculations, we need to set our class properties so that we can use it further. Now this pager class will deal the entire pagination thing, but we want to deal our data also, so for that we need to create an other class which will display pagination on front end. As we can receive any kind of data in this page data class, so we just generalized it. In this class we will have two properties. One is pager, whose type will be pager, that we will create in a few minutes back. Second will be data, whose data type will be template type. Next we need to define its constructor. So this was our pagination DTO. Next we will see its use in our services class. Hope so you understand it. So after creation of our repositories and extension methods, now we are going to create our services. First of all, we will create our customer service folder, in which we will have our customer service class and customer service interface. Now in this folder, first I'm going to create our customer service interface, and I'm going to prefix it with I. In this interface we will declare only functions and then implement it in its class. Now let's create our customer service class, in which we will implement its interface. Now in service interface we have to implement all our repository functions. Let's copy it. But there will be one difference in customer service functions and customer repository functions, and the difference is their return type. In services we are going to return DTO types, but in a repository we were returning entity types. Also in interface we have a generic return type, that is response DTO. Now we need to replace our entities with DTOs and then return it in response DTO. Entity status will be same. Now in place of tuple we will have page data here, and here with response data we will pass page data. Now in this page data class we need to define its type, so we are having here customer DTO type of page data. So guys, these are our 4 functions which we have implemented in our repository. Now we are extending it in service just to implement our business logic here. Now what we need to do, we need to implement these all functions in its service class. In this customer service class, we want to implement dependency inversion, and for that purpose we are going to define constructor first. Now we will create private read-only object of this iCustomer repository. Instead of constant we are using read-only here, just because we can initialize read-only object in constructor, instead like constant object that must be initialized right after the declaration. Now as we are implementing dependency inversion here, so that's why we are creating object of iCustomer repository instead of its class. Next, let's implement all the functions of iCustomer service. First, let's implement delete by ID function. Now let's create response object and implement our logic in try catch. Now first of all let's implement our error case. In case of error we will send response status.error. with exception dot message. And then just return response. Now in try block, let's implement our logic. Now in result of response, we are going to save our delete by ID response, which is coming from our customer repository. As is async method, so we need to write await here. In the same way, we need to implement the logic for all the functions. So all the error handling we are dealing here in services. Now in case of filter function, we are calling same function from repository and passing the parameter filter sort column etc here. Now first of all we need to get customer list tuple dot item1 dot to DTO list. Now we are using two DTO lists which we already created in our extension folder just to convert our entity type to DTOs, which we are going to display on front end. Next we need to initialize our pagination object. So this is our filter function. Next functions are most probably like delete by ID functions. Let's just see them. But the only different thing is if we want to display data on front end, then we need to convert our entity type to DTO types. But if we want to save our data, then we need to convert our DTO types to entity type. For that purpose, we already created our extension functions to DTO, to entity, or to DTO list or to entity list in our extension lecture. If these conversions are confusing you, then I guess you need to see this lecture, which I have mentioned in description and on the screen too. So this is it for services. Hope you understand this entire lecture. If you have any question, then you can ask in comments. After the creation of our repositories and services, now first of all we need to create our objects by dependency injections. Now by services we need to inject our DB context, builder.services. Now we just provide our DB context here, customer DB context. In options, we are providing a provider which we are going to use. We are going to use SQL Server, which I mentioned here. In its parameter, I am going to pass connection strings name. Next, we need to add repository. For repository, we will use add scope, which will define that our per HTTP request will create only one object. For dependency inversion, we have three kind of scopes. One is singleton. Singleton will create one object for our entire application, and scope will create one object per one HTTP request. But add transient will create object every time. Now we are using add scope for our repositories object and for our services object. First I'm adding scope for iCustomer repository and customer repository. And same we will create for our service. Now we have created objects of these three DB: context, repository and services by dependency injection. Next we need to create our customers controller. Here we are using controller base. Now let's define route first. Now let's use another decorator, which is API controller. Now again we will use the same function we created in service and repository. Now what will be the basic function of controller is it will works as a bridge between front end and back end. If we want to save data in our database, then this controller will receive data from front end and pass it to the service. Otherwise, if we want to display something, then our controller will get data from service and display it on the front end. Let's copy paste all the function we have created in our service. Our controller functions will be public, and on every function we will define method access, like how we access our method, such as get, post, put, delete. Now here for get by ID, I'm going to write http get. But before that, we need to inject our service by dependency injection. Now by this object we will implement all the methods, as we have already written our business logic in our services. So now this controller only returning service values. For save function we will use http post, and for delete we will call http delete. For filter again we will use http get. Now we need to define the route. Now we can simply define route on the controller only, but also we can define route separately on each function also. Now let's see it. If we don't define routes on the methods, then we can also get these functions by these HTTP requests like get, post, delete. Then it will be a RESTful API. Now as we are defining a route for each method, so it's a REST API but not RESTful API. So now we have completed our backend. Now in next lecture we will see our front end. But still, if you have any question, any confusion in our backend series, you can ask in comments. After the completion of our server side, now we need to move towards our client side application. In this client app, we have to work on our next development for front end. So we will start by our home controller, and first of all we will remove this entire HTML. Let me just write a title for a moment. Now let's move to its component, and after writing the entire logic in its component we will move to the HTML again. So let's start. Now I'm going to implement onInit. This onInit interface have one ngOnInit function, and after this function we need to write our constructor here. Constructor we use for default initialization and dependency injection, while ngOnInit used for data initialization. Now by dependency injection we will import HTTP client in our constructor, which is built in. Then we need base URL of our application. Next, we need to initialize a variable of customer list in which we will store the result. Next, we need a base URL variable. Next, I'm going to write a function load data in which we will load the customer list from server to client. Now we use get call by HTTP client for accessing our customer list. Now with base URL we will define the route we define on our controller. Then we will use filter method URL, which was filter with parameters. Now in this case we don't want to use our filter parameter, so remove it. So we will use other parameters for a moment. Sort column will be ID and sort order is ascending. Page number we are giving here 0, which will show our first page, and page size will be 20. We must need to subscribe our observable to get response from the controller. Before saving our response, we need to check either our response is failure or success. As we defined status value is 1 in case of success, so we will use the condition status is equal to 1 in case of success. Now in success case, we will save our customer list in customer list variable. Now we need to call this function in our ng-oninit function. Next, we need to define our controller in our proxy file. If we don't give controller's path in our proxy file, then we can't access it on frontend. Basically, our frontend application is on another port and our server-side application is on another port. So proxy is used as a bridge between both the applications. Now HTML which we need to use in this application I have already written. Let's copy it and paste it in our HTML file. Let's run our application to display data on front end. Now our application is loaded and it displays the list of customers. Also we have added, delete and add buttons here on which we will work later. Now before moving forward, let's see what I have done in our HTML file. In HTML we have a customer list for loop and also we have add button, edit button and delete button. In our loop I am displaying 3 attributes: first name, last name and is active. So this is it for customer list part. Now we will see add, edit, delete functionality in later parts. If you have any confusion, you can ask in comments. After listing, now let's implement the functionality of delete customer. For this, first of all, I'm going to write delete function on click in our HTML file. And in delete function, we need to pass ID because on base of ID, it will delete our customer. Now let's implement this delete function in our TS file. Now before deletion we want confirmation from our user that he actually want to delete the data or not, because sometimes may someone press delete button accidentally. So to remove this hurdle we implement this confirmation box for deletion, either user want to delete this customer or not. For this confirmation we will use an external library. Let's see it. I'm going to share this library link in our description, and now I'm going to install this library in speed mode. After installation, we need to include these two commands in our app.module folder, and its CSS file must need to be included in angular.json file. Now for the access of this service, we need to include it in our constructor so that we can use it in our component later. Now let's call warning function here for the success or failure condition. Now in success case, we need to implement our delete customer functionality by using HTTP client, exactly like we have done already in our get listing function. After subscription, we need to call load function here so that our page reload right after the deletion of any customer. Now let's run this application and test the delete functionality. Now if we click on the delete button, it's asking for confirmation. Now in case of yes only, we can delete the customer and page will be reload and show the updated list of customers. So this was the delete functionality we have implemented. If you have any confusion, you can ask in comments. Welcome back everyone in this full stack series. After the creation of our listing and deletion page, now we are going to work on our add edit pages. For add edit pages, we need to add a component. Let's write the command of add edit component. ng generate component and then name. For generate, we are going to write G, and for component, we are going to write C. So ng G C add edit customer. This is a name, you can give anything. And then we can also add module in it. As we just created this module, so there is nothing in this module. First of all, we are create its route. So let's add routes in our module file. Add route is simple, but for edit I'm going to add ID parameter, cause by passing ID we will edit our customer. But in both the cases we will call a single module, which is add edit. Now in this component we need to add reactive form first of all, which will represent our data. So now let's create our form by using form builder. So for now, this is our form which we need to bind with our DB. Now I'm going to write HTML for this form. Now after creating the HTML form, I need to bind our component form with this HTML form. So I'm going to copy the form name from TS file and going to bind it form tag. By using form control name also we need to bind its properties. To check that our TS and HTML form is bind or not, I'm going to give default values. As our form is showing default values, so our reactive form is working correct till now. Next, we need to write the functionality of the submit button so that when we press submit button, it save our values or our form. For that, we need to write save function on our submit button. Now in this save data, first of all we check either our form is valid or not. Now we will call our server by using HTTP client as we have already done in our previous lecture for listing and delete function. Also we need base URL which we will copy from the previous component. Now by using these, let's call save function. As we want to save our data in database, so we will use post call here. Exactly like before with the base URL, we will pass complete URL of save function and then save this form in database. After subscribe, we are just going to redirect it on the listing page. For redirect, I need to include activated route, so let's inject it. And route also. As we have our listing page in our home controller, so we just need to pass slash to navigate on home controller. Now we need to perform our edit case. In edit case, we need to check in our route we have ID or not. For that, we need to use activated route. So if we have ID or param in our route, then it's edit case. Otherwise, it will be a add case. Okay, now in this case, when we have RD not equal to null or not equal to empty, then we will call edit case. As we haven't written any added customer function, so first of all let's write that function and then call in this if condition. In this added customer function, we need to call our get by id function from controller so that we can edit the customer on the basis of this given id. Okay, after subscription, if we get success response from the server, then we need to save the result in data and then we need to patch value by using this data. Patch basically used to update or edit our values. After added customer part, now we need to include the routes in our HTML file of home controller so that our add edit button will be clickable or workable. So let's add routes for add button and edit button in our home controller, for which we will use anchor tag. Now let's run our application and test it. If we click on add button, it just go to the add page, and if we click on the edit button, it will redirect to our added customer page. So this is it. This series of full stack development is completed now. We have shared with you database, a C# code, and then now front end code. Hope you understand this entire flow. If you have any confusion, you can ask in comments. Thank you.